Imagine taking a lighter to a massive stack of cash. Now imagine that stack is $327 million high. That sounds insane, right? But that is exactly what NASA effectively did on September 23, 1999. They spent years building the perfect machine. They hired the absolute smartest engineers in the world. They calculated complex trajectories across millions of miles of dark, empty space. Everything was supposed to be perfect. But there was one thing they missed. One simple, silent error hidden deep in the code. It wasn't a complex computer virus. It wasn't sabotage. It wasn't even an alien attack. It was a math mistake so basic, so elementary, that a high school student would be embarrassed to make it on a homework assignment. Today, on Silent Error, we are going to investigate the most humiliating disaster in the history of space exploration. We are going to uncover how the world's premier space agency crashed a state-of-the-art spaceship simply because they forgot to convert the units. But before we dive into this multi-million-dollar disaster, let's be honest in the comments. I want to know who is watching. Be real with me. How were your grades in math class? If you were terrible at math, comment, "I hate math." If you were a genius, comment, "Math wizard." Let's see who is watching. Because trust me, the genius engineers in this story, they definitely needed a tutor that day. To understand how this happened, we have to go back to the late 90s. This was a unique era for NASA. They were operating under a new philosophy called better, faster, cheaper. The goal was to build efficient spacecraft without spending billions of dollars like they did in the Apollo era. It was an ambitious time, and the jewel of this new program was the Mars Climate Orbiter. This wasn't just a chunk of metal and wires, it was a masterpiece of modern engineering. It was a robotic space probe designed to become an interplanetary weatherman. Its mission was critical: orbit the red planet, study the Martian climate, look for water, examine the dust storms, and search for clues about potential alien life. It was supposed to be the eyes and ears of humanity on Mars. The journey began on December 11, 1998, launching from Cape Canaveral Air Force Station in Florida. The launch was flawless. The Delta II rocket roared into the sky, piercing the clouds and leaving Earth behind. For the engineers on the ground, it was a moment of pure triumph. The bird was away. The hard part was supposed to be over. Now all they had to do was guide it through the vacuum of space for 9.5 months. It seemed like a routine cruise, but they didn't know that the seed of destruction had already been planted before the rocket even left the ground. Space travel isn't like driving a car. You don't just point the steering wheel at Mars and hit the gas. The spacecraft is constantly being pushed around by the solar wind and light pressure. To stay on track, you have to make tiny, microscopic adjustments to the course every single day. These are called angular momentum desaturation maneuvers. Basically, the ship fires its small thrusters to keep itself steady and pointed in the right direction. To manage this complex navigation, NASA relied on two separate teams, and this is where the trouble started. One team was the navigation experts at the Jet Propulsion Laboratory, or JPL, in Pasadena, California. The other team was at Lockheed Martin Astronautics in Denver, Colorado, who built the spacecraft. These two teams communicated constantly via email and file transfers. They were sending critical navigation data back and forth. They thought they were speaking the same language. They were wrong. They were about to commit the most expensive communication error in history. You see, in the world of science, the standard is the metric system. Meters, kilograms, newtons. NASA explicitly required all software to use the metric system. But the engineers at Lockheed Martin, they were old school. The software they wrote to control the thrusters calculated force in Imperial units, specifically pounds force. This created a silent, invisible disaster. Every time the thrusters fired, Lockheed's software said, "I pushed with 1 pound of force." But NASA's computer received that number and interpreted it as 1 Newton. Since 1 pound is equal to about 4.45 newtons, the computer was underestimating the force by more than 4 times. Every single day, for 9 months, the ship was drifting slightly off course. At first, the error was tiny. A few millimeters here, a few millimeters there. But space is unforgiving. Over a journey of 416 million miles, those tiny errors compounded. They added up. The Mars Climate Orbiter was slowly, silently drifting closer and closer to the planet's surface. Some navigators noticed that the trajectory looked a bit weird. They saw discrepancies, but they dismissed them. They trusted the code. They trusted the machine. September 23, 1999. Arrival day. The atmosphere in mission control was electric. There were peanuts on the desks for good luck, a NASA tradition. The engineers were excited. They were about to make history. The plan was for the orbiter to fire its main engine, slow down, and slip into a nice, high orbit. The target altitude was 226 kilometers above the surface, a safe distance. But because of the math error, the ship wasn't at 226 kilometers. It was at 57 kilometers. That might not sound like a huge difference to us, but in orbital mechanics, it is the difference between life and death. At 57 kilometers, you aren't in space anymore. You are deep in the Martian atmosphere. The Mars Climate Orbiter hit the atmosphere at thousands of miles per hour. The friction was instant and violent. The delicate gold foil ripped apart. The solar panels snapped. The antennas melted. Back on Earth, the screen showed the spacecraft going behind Mars. This was expected. They waited for the signal to return on the other side. "Waiting for acquisition of signal," the announcer said. 5 minutes passed, then 10, then an hour. The room went dead silent. The peanuts remained uneaten. The realization hit them like a cold wave. The bird was gone. $327 million of taxpayer money had just turned into a streak of smoke and debris in the Martian sky. The investigation that followed was brutal. When they found the cause, the pounds versus newtons conversion, it became a global joke. Headlines mocked NASA. How could the smartest people on Earth make a mistake that a high school physics student would catch? But the real lesson here wasn't just about math. It was about the danger of assumptions. It was about the silent error of poor communication. People suspected things were wrong during the flight, but no one spoke up loud enough. The math was just the bullet. The silence pulled the trigger. This disaster changed NASA forever. Today they check their units double, triple, quadruple times. Because they learned the hard way that in space, you can't just wing it. Sometimes the biggest ships, the most powerful rockets, and the most expensive projects are brought down not by huge explosions, but by tiny, invisible mistakes. A key in a pocket, an open window, or a missing conversion from pounds to newtons. Now, I want to know who really watches these videos until the very end. If you made it this far, comment the secret password, Red Planet. I will be hearting the comments of everyone who knows the secret. Don't forget to subscribe for more stories about the tiny errors that sank the world. This is Silent Error. See you next time.